Thank you all for being here. I really appreciate it. And I know we all have busy lives, classes to teach, classes to attend, family. It can be really difficult to make it down to these seminars, but I really appreciate you all being here, your support. It's a really nice day out today, and I'm really excited about this talk, but I know you also would like to be out in the sun as well, so I'll make it short, but not too short. Now, so let me give you a brief idea of why I went in this direction, what interested me most about the origin of numbers. Overall, it started way back when I was in middle school, high school, where I didn't really know much about mathematics, specifically with numbers, what they meant, how they came to be. They seemed like they were essentially the fundamental aspect of numbers, at least in my eyes at that point in time. Of course, that view changed slightly over the years as I started to get more into algebra and trigonometry, and more symbols versus numbers were being used. But nonetheless, it piqued my interest recently when I was in, right now that I am in the History of Mathematics seminar with Mr. Dersch leading the class. Another reason why I have such a big interest in the origin of numbers is because of my kids. I have a 4-year-old, and she can count all the way to 20. But one day I got to thinking, what does that actually mean? Is she just memorizing the words? Do they actually represent a quantity to her? In other words, are they cardinal numbers to her, or do they just represent an order in which things come? Are they ordinals? So that kind of sparked that too. Last week, Thursday, Carolyn Evans gave a great, just awesome talk on the Pythagoreans. And one of the things mentioned was how big they were on numbers and how religiously they followed them and practiced them. Unfortunately, I'm not that kind of person, but I do think numbers are really awesome. And again, that pushed me more towards learning more about them. A quick disclaimer. Most of what I'm about to talk about today is an overview, a simplified version of very complex material. Some of it dealing with observational data with children, adults, even some primitive cultures that are still around today that could give us a glimpse as to how numbers could have developed. It's based on the psychology of the brain, archaeological finds, and really it's just a description, an attempt to try to learn what early peoples went through and discovered to get to what we have now. So it's not a perfect model by any sense of the word. But for the most part, it does attempt to identify some key features of number development. I'd like to start off with a demonstration / activity, more of an activity. I have some toys here, specifically because I wanted to add a little personal touch. And what I would like to do, or what I would like you as the audience to do is, I'm going to arrange these toys in a specific manner. When I signal you, I would like you to close your eyes while I rearrange them. When I ask you to open them, try to identify how many toys are here without actually counting one by one. So if you want to go ahead and close your eyes now, that would be great. Go ahead and open and try to identify how many numbers there are without counting. Okay. I'm going to do this a couple times. So go ahead and close your eyes. And go ahead and open. Okay. Close your eyes once more. And again, open. 2 more times. So go ahead and close your eyes again. Open your eyes. Again, trying to identify. And last time, go ahead and close your eyes. And again, without counting, attempt to identify the number of objects. Go ahead and open your eyes. Okay, so did anyone have any trouble identifying quantity without having to count 1 by 1 or 2 by 2? So maybe just a little bit. In the book, The Universal History of Numbers, if I remember correctly, the author, George, I'm drawing a blank, George Ephraim talks about this idea called number sense, in that we can only grasp, without having to count or use one-to-one correspondence, we can only grasp the idea of up to 4 numbers. Now there are outliers, there are people that are able to do more than just 4, but generally speaking, up to 4 numbers. The same idea is re-emphasized in the book Where Mathematics Come From, and these specific authors, George Lakoff and Rafael Nunez, call it subitizing. And they actually go on to talk a little bit more about what that means as far as basic arithmetic and counting in the general sense. We can identify up to 4 objects. We can also know when we have one or more thing missing, as long as it's in a small range of numbers. So for example, if I have 2 apples and I add another one to my pile, like I know right away without counting that I have 3. Same thing can be said if I start off with 4 or 3 apples and 2 get stolen, then I know I have the appropriate amount, 2 or 1 depending on my starting amount. And again, this isn't arithmetic in the sense that we take 30 and 40, add them together, and we get 70, or we take 50 and 5, and we get 40, and subtract them, we can get 45. This is more of an intuitive, I know I have 1 missing, I know I gained 2, I know I added 2, that type of arithmetic, basic arithmetic. Now, back to the Universal History of Numbers, the author talks about 3 stages of number development. With the origins of numbers, there are many different directions I could have taken this, but I decided to concentrate on these stages to get an idea of where our numbers specifically came from. The first one being number sense, or one-to-one, which I somewhat demonstrated here in the beginning. Stage 2, which is counting, but counting in the sense of using repetitive techniques. And then we have the 3rd stage, which is numerical nomenclature, which I'll go into detail here in a second. So again, this information that I'm about to talk about is based on both observing current primitive peoples, the study of the brain, so on. A lot of early civilizations had words for the number, what we consider the number 1, the number 2, and then a word for many or a lot. And what would happen is if they wanted to describe 3 or 4, sometimes they'd get a little clever and they'd say, of course in their own language, something along the lines of 1 and 2 or 2 and 2, or 1 and 2 to represent 3 and 2 and 2 to represent 4. And so in a sense, that was kind of like our present day positioning system, in the sense that you can have groups of things, but it didn't really go beyond 3 and 4. So it can't necessarily be considered a positional system in that sense. But it was very useful for these people's specific needs. Many things were used to keep track of things. The idea of one-to-one correspondence, basically, as I have in the image to the right, where if you take a number of objects and you can make a direct link between another object, an animal, livestock, property, anything. And so civilizations use tallies, sticks, pebbles, fingers, body parts for counting in that way, one-to-one. And again, when I say counting, I'm really referring to identifying one pebble to, for example, one cow. When farmers needed to keep track of their animals, when they would go grazing, the farmer, for example, could get a bunch of pebbles, one by one, as one animal left, put it in a container. And when the animals came back, they would just have to do the opposite, take one pebble out, one at a time. And at the end, when all the animals returned, if there was no pebbles missing, if there was no pebbles left, I should say, then that would mean that all the animals returned. If there was not enough, that would mean that somehow the person acquired an extra animal, or there might have been some counting, like pebble mistake at the beginning. If he had one pebble extra, then he'd probably be really mad and try to get a hold of his neighbor. So you can imagine how that could have gone. I do want to pass around an example of one-to-one correspondence without counting. I have a rosary here. I am a Catholic. My goal here isn't necessarily to bring religion into the conversation, but just to show that there are some times when you need to be able to keep track of how many things you do, in this case, how many prayers. And that's what the beads are for. Every prayer, or every sets of prayers, I should say, you'd be one step closer to the end of your overall prayer session. So this is another example of one-to-one correspondence without having to count in the sense that we consider counting today. But I'll go ahead and pass this around. Now, so stage 2 is, these stages overlap a bit. So we bring in the idea of one-to-one correspondence, but now with repetitive actions. So like, for example, a rosary, repetitive counting of beads, or if a civilization is using their fingers and their body parts to do one-to-one correspondence, they'd use these techniques. An example is using the whole body. I believe, okay, so the villages below the Musa River in British Guinea, which I actually didn't know where that was, if I'm even pronouncing it right, until recently. But it's basically an island to the northeast of Australia, where the people used their whole body for counting. So, for example, the number 7, they would start with their right hand, their pinky. They would go all the way around, and I have an image there too. It's really hard to see, so I'll describe it. Right hand pinky to the thumb, and then up the arm, into the eyes, the head, all body parts, back into the left arm, finish at the pinky, and then continue through the rest of the body. So for example, counting our number 7, they would go, and again, this isn't in their language, but 1, 2, 3, 4, 5, and then right here is 6, and then elbow 7. And then if I remember correctly, continuing, the shoulder would be 8, and so on and so forth. As far as practical uses of this, whenever tribes would go to war and one tribe required payment for loss, for example, from another tribe, or maybe payment for some other reason, one tribe would send a messenger, and what would happen is the messenger would essentially carry with him a sequence of these steps of counting with them, so they knew how much, quote unquote, to request from the other tribe. And so the messenger, when he arrived, he'd say, for example, right here it says necklaces, 10 necklaces. He'd explain the reason for his visit, all the formalities that are involved in such a thing. And to the people that he'd interact with directly, he'd say, I need this many necklaces as payment. And he'd actually go through the motion of counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the other tribe would respond with, okay, and they'd go to their ruler, their king, whatever their title was, and then the king would either accept or deny, and then they'd return. And so while someone gave a necklace, another person would do a one-to-one correspondence. So every one necklace, they'd increase their counting. So they weren't necessarily counting in the sense of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They were really just using their body parts to know for certain that they had the quantity they needed. So in certain respects, the body part where they would land at would kind of represent a cardinal number, but not exactly what we consider a cardinal number. More of like I need a shoulder of necklaces, or something like that. The words for the body part were used interchangeably, and really the context was really what defined what the word meant. So then we come to stage 3, numerical nomenclature. This is where it gets closer to the numbers we have today, in the sense of this is the stage where numbers themselves start getting dedicated names for the specific symbols. For example, I should write this up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and each one would have their own verbal name. So for example, 1 through 9. Uno, nueve in Spanish. I'm drawing a blank of somebody. Oh, I have it up here. I don't need to draw them. Arabic, Wahid, Itnain, Tisas. I'm drawing a blank on the exact names, but you get the idea. And so our specific numbers, 1 through 9, short answer, it comes from the Arabs. But to be more specific, they actually got their nomenclature numbers from the Hindu, ancient Indians. Some of the evidence that this is the case is there's slight similarities in our numbers, which we now call Hindu Arabic numbers, are written from left to right, as well as our writing, our literature. It's written from left to right. The Arabs actually write from right to left. The Hindu also write from left to right. And yet, the Arabs write all their words from right to left, but they write their numbers from left to right, which again hints at them getting them from the Hindu. And again, just to make it very clear, this is a really simplified transition from one type to another. So these are, notice how on this top line there is nothing for the number 0. That is because only a few civilizations actually discovered, so to speak, the number 0. One of them being the Indians. If I remember correctly, I'm drawing a blank here, but definitely the Indians were able to discover it, which eventually carried on down to what we have today. So essentially the number 0, it's its own, it's more or less a story for another day. So here I have a slightly more detailed branch of how these numbers came to be as they are visually. And actually, I just want to be clear that these diagrams are simplified from their original version because there was so many other branches that it would have just been cluttered on the screen. So I just mainly concentrated on the branches that led to our numbers and some of them that were close enough. So here we have, again, the Indians up here, and then slowly progressing into Arabic, and then European numbers, and then the modern number 1. Here we have same thing. We start off with early on, numbers had very simplistic meanings, in this case two lines, and they moved on to the Indians and then off to different branches. Here we have the Eastern Arabic numeral 2, and our version of the modern number 2. Now, this is one of the numbers that I found really interesting, just because if you notice from these steps in overall writing, it kind of looked like someone just changed up the, took artistic initiative to make it look a little different, or maybe just had sloppy handwriting. And so you can see that from here to here, and even to these, there's only slight differences in the symbol, and eventually ending up with our modern number of 3. Now here we have number 4. Here we have 5. And again, a lot of similarities, at least until you get to the later parts of the branch. This is another one that interests me, because right here, if you look at this symbol, if you go over directly to the right, more emphasis is put on this small loop down here, whereas the branch that leads to our number 6, more emphasis was put on this top portion of the loop. And so we get our present number 6, whereas the Arabs have more of a 7-looking number symbol. Here we have the number 7. Again, a lot of similarities, minor changes from branch to branch. Some of these are pretty interesting, like just a triangle for the number 7, a Y-looking letter for the number 7. So these, yeah, let me be more specific on that. These time frames, I'm not going to lie to you, I didn't even attempt to memorize. But if I remember correctly, it was no. Yeah, it's like, when I say European, I mean the areas that were really nearby from what the present day, what we consider like the Arabian Peninsula, and so it'd be areas closer, so like Germany, Italy, like those areas. I don't necessarily know exactly where these numbers were used, but generally speaking, they tended to be areas closer to trade routes, and yeah. So I have all of 1 through 9 up here. They'll come up. Maybe. Okay, yeah, so here's 9. And again, like I mentioned, if I gave you the whole graph, there's more that branch off up to the top and left. But again, I didn't want to make the screen too cluttered, because then it'd be a really tiny number and you wouldn't be able to see it. But that's the general trend into what we now have, in this case, the number 9.
So what that's saying in the lower left corner, where you got all those amazing symbols for what we now refer to as 9, that's European, and those are different with regard to geography, or are they temporally different, or is it both?
They're mainly, the reason why there's so many is one by geography and practice. Some of them were based on findings from like actual physical archaeological evidence of, hey, we found an example of something that looks like this. But yeah, generally speaking, essentially by profession, and I guess if I can say that, by what people partook in. Yeah. So then with the stage 3 nomenclature numbers, it gives the basis for numbers and numbering systems. And to keep things simple, I'm going to be using R base 10 system to kind of highlight the different base numbers. As you all know, we use base 10 to represent our numbers, where each place value represents a power of 10. As you can see here, we start to the left of the decimal. We have whatever's here times 10 to the 0, 10 to the first, 10 to the second, so on and so forth. And we can also go in the opposite direction of 10 to the negative first, 10 to the negative second, 10 to the negative third. This is actually base 10, according to what I read, seems to be the most widely used base system around the world, generally speaking. It has it has a lot of advantages. And when I say widely used, not all civilizations had exactly this system, but they group things in terms of groups of 10, groups of hundreds, groups of thousands. So then we have base 2, or binary, essentially the language of computers. Whereas base 10, we can use the symbols from 1 to 9, including 0. And base 2, we can only use 1 and 0. Regardless, this method essentially still applies, where the ones place would be whatever symbol is here times 2 to the 0 power. Whatever term is here times 2 to the first power, 2 to the second power, 2 to the third. And you can actually use this technique for any of these bases. I'm not 100% sure that computers use a decimal. I don't think they need it. But if we were to take the same concept and go over to the right of the decimal, you just have 2 to the negative first, which would be a half, 2 to the negative second, or I'm sorry, 1. Yeah, 2 to the negative second, which would be a quarter, and then an eighth, so on and so forth. Now, civilizations that had numbering systems in different bases, they didn't all have this system that allowed for these place value ideas, because they didn't all discover the number 0. For example, if we had 101, there's that placeholder 0 there to signify that there's no groups of 10 to the first power, or the number 10. So what some civilizations used to get around this without having to discover, so to speak, the number 0, was they actually just left a gap. So an example is the Sumerians, who had base 60. They would, for example, if they needed a number, I'm drawing a blank. for simplicity's sake, I'm going to use our numbers to represent what I mean. This number would have a 1, and then instead of having a 0, they'd leave a blank, and then they'd have another 1. So that would be 101, quote unquote, which might seem crazy, because what would be the difference between this and this if all we had was a gap, right? And so in those cases, the context of the number is what gave it its meaning. And while I don't necessarily know how people were just good at doing that, it was done, so I would imagine it worked for them. There's still some remnants of this system left in the world. For example, our clocks, there's 60 minutes in an hour, there's 60 seconds in a minute. So that's that idea of grouping by 60s, base 60. The Mayans, if I remember correctly, they were one of the civilizations that discovered their version of the number 0. They used vigesimal, base 20. If I remember correctly, not all civilizations stuck to one base number. Sometimes they would use various ones that were similar enough. I believe the Mayans also used base 5, if I remember correctly. But generally speaking, not all civilizations stuck to only one base number. And then we have base 12, which wasn't necessarily something discovered as being in use throughout history, but it's a base system that has been suggested as a potential replacement for base 10. One of the reasons is that the number 12 has way more factors, and so division and fractions would be a whole lot more easier, as well as a whole set of other ways of calculating. So it's, in a sense, it's supposed to be a better way of calculating numbers. So one of the good things about base systems and how they work is that you can take, for example, a base 10 and convert it to base 2 to binary. You can convert it to base 12. You can to any base numbering system, which is fun, because then I'll show you what I mean by that. So what I did was I took my name, converted it to each individual letters to a number based on their order in the alphabet. I added them all up, and then so I got 49 for my first name. I multiplied it by this number. The reason being mathematical, I guess. So I get this number. And for those of you who aren't familiar with converting base 10 to another base system, you basically just take the number that you want to convert divided by the new base's number. So in this case, I want to convert it to 48, base 48. And the remainder of each iteration of division is going to give you your new number in that base. So for example, the first iteration of division, I get that with a remainder of 1. And that number 1 is going to be in quote unquote the ones place. And we take that top number, divide it again by the base, and continue until we get to essentially 0. And so we get that number. And for those of you wondering, why would I even do this? Well, I pondered the idea of there have been people throughout history that attempt to prove that certain individuals are quote unquote the Antichrist by saying that their name represents a certain number, in this case 666. But I wanted to take a lighter approach, so I settled on 1111. So essentially, next time you see me, think 1111, make a wish, and I really hope to brighten up your days and your day in that way. But thanks. Are there any questions for me? Go ahead, Don.
So one of my questions was when people started using numbers for different different cultures, how was it universalized? Like, how was it determined that we're going to use this symbol for a particular number, this symbol for a particular number? Was it just by popularity? Like, did so many people just use this symbol, they just kept keeping it, or that's one of my questions.
Okay, so Don asked, how did numbers get selected? Was it by popularity? Was it by the different interactions? Does that sound about right? So my response to that is, kind of goes back to one of the questions that Mr. Dersh asked in what time frame, where were these numbers used? And a lot of it has to do with the situations that individuals were in. If a specific system worked well, and if enough people understood it, then that kind of hints at one reason for using something over another. And so, for all we know, many people knew a better way of working with numbers, but if you have a larger population that doesn't necessarily know how to use it, it kind of becomes, in that sense, not as useful. And so specific forms of numbers tend to be more widely used and prevalent, especially if you're dealing with trade, travel, where, knowing, even with, travel specifically, navigation, if you needed to communicate a trade route or way of getting somewhere that involved navigation techniques, then you'd want to have a similar or at least close enough numbering system that would work for at least the majority of the people involved. So, yeah. Go ahead, Caroline.
In your studies, did you come across a dead system that you liked more than the system we use now, or you think would be better suited to what we do?
So Carolyn asked if there was a system during my studies that I found that might have died off but seemed really cool. To be honest with you, I'm so used to base 10 that I wouldn't necessarily say that anything's cooler than that, just because I like it so much. But if I go back to my slide, there were some that were pretty neat. I don't know why, but I do like, as far as for like aesthetic reasons, where is it? Might take me a second. The Hindu numerals, I believe it's Sanskrit. I don't know if necessarily that it's dead, but as far as one of the cooler ones that I liked, it would be that one. And again, more for, appearances. Yeah. Go ahead, Nancy.
The number system that was base 60, I'm thinking how hard that would be to assuming they must have had, well, if you include a zero, that'd be 61 distinct symbols. I wonder if they had any shortcuts to.
Yeah. So Nancy mentioned base 60 and how difficult it could have been to actually calculate and use those numbers in a meaningful way. And actually, so when I say the Sumerians, it's actually a large time period. There are two prevalent methods that were used. One of the methods involved, if I remember, clay tablets and punches or presses to like make indentations into the tablet. And I don't remember the actual value, so forgive me, but a number could be like an indentation and then have another little indentation signifying a specific thing. And they would have tablets for, I believe it was kind of like our version of a multiplication table, but with using their numbers. But they also had another version of later on that became more prevalent, and it kind of looks like this, where they had these symbols kind of next to each other, representing different symbols. Yeah. But they definitely did have their own form of multiplication tables, and I believe even addition tables. As far as, if I remember correctly, the addition tables, they either weren't, I think I'll stop there before I say something that I don't know for sure. But yeah, they did have shortcuts. Anyone else? Dom?
I can recall trying to teach different bases to eighth graders back in the late 60s. No matter what base you were in, when you got to the second place, it was always 1, 0. So if you were in base 5 and you had a group of 5, it was 1, 0. It would really confuse students because 10 to us is 10.
Yeah.
And then you see 1, 0, they want to read 10.
Yeah.
It's not 10. We had a lot of fun with that, trying to, especially base 12, when you would put 1 through 9, and then you create two symbols to get to 1, 0.
Mm-hmm.
One group of 12. So
Yeah.
it was really, as a teacher, and being exposed to that as a student, it was really eye-opening to myself as well.
Yeah, and so even to someone, at least from conversations I've had in the past, even someone that's familiar with different base numbering systems, it's difficult to just have that mindset of seeing 1, 0 and thinking automatically 60 or 12 or 5. It's because there's no immediate practical use for them. It's not something that you delve yourself into. Like learning a language, if you're in the country that speaks that language and you're immersed in it, regardless of whether you've taken a formal class or not, eventually you're going to learn something and it's going to mean something to you. Whereas if you just take a class and never use it, well, you might be able to recognize it, but it doesn't necessarily mean anything in your head as far as like an actual physical object or a gesture or an action. But yeah, it's very difficult to make our minds think in that manner.
Saginaw Public Schools in 1965, they decided that we all needed to learn base 6. I would love to talk to my 4th grade teacher at that time and find out why that was necessary, and I'm sure it was not her idea.
Yeah.
It was done citywide, and
Wow, that's
I'll tell you
intense.
two things. First, I had no idea what was going on. Second, to this day, I know that 6 to the 4th is 1296.
It's impressive, very impressive.
Did you come across anything that indicated as some of these systems became more popular, what percentage of a population
As far as the statistics of how many, or at least what area, how much of an area used what numbering system, I wouldn't be able to actually answer that truthfully. Yeah, I don't want to lie to you, so I'll leave it at that. I do know that last semester I took world history up to 1500, and up to the early portion of, or essentially mid to end portion of the 1400s, most of, wow, I'm drawing a blank. Up to that point, most activity and knowledge of most forms, not necessarily mathematics, was centered around like India, the Arab Peninsula, Africa, Asia. And so, which kind of makes sense that our number specifically came from the Indians. There was a lot of knowledge floating around there. As far as Europe and like the UK, which is basically its own little island off to the side, they weren't as active. And that's not to say that they were dumb. They were not by any means. They were just active in different ways. Unfortunately, I didn't take world history from 1500 and forward, so I wouldn't be able to say much on that. Yeah, I hope that that at least attempts to answer your question. So, any more questions? Excellent. Well, seeing none, I think it's fair to say that some of us would like to be out in the sun, if it's still out, assuming.
Thank you. That was really great.